Now, just to refresh, in chapter 6 we have covered this part, simple trusses, method of joins, and zero force member. So we have been introduced to what is truss, what is it exactly, and we have refreshed also two force member, right? And then we go to zero force member, how to identify zero force member in trusses, and then we have covered method of joins, where we actually focus on the pin or the joint to draw free body diagram and then solve. So we have covered that one. So this part is settled. The next part in the textbook is actually method of sections, but we skip totally this part, where this is another method to calculate the same thing. As mentioned, this will not be covered in statics, but for those automotive and aerospace, you still need to cover this if you want to go for other subjects later on. And then we'll go to frame and machines, right? So this is another two other types of structure that we can have aside from trusses. And for this part, the objective is for you to be able to draw free body diagram and then determine the forces by solving the equation of equilibrium, basically. Right. Now, so what are frames and machine? And to begin with, I'm not sure if you, by looking, you can differentiate how it is different from trusses. This is obviously different. Right? So this is machine, this is trusses, frames. Right? Now, how is it different? Alright, generally speaking, frame, how it is different than truss is basically it will have at least one multi-force member. Meaning, for example, here you can see there is a two-force member here, but this is more than two-force member, etc. So it becomes free, right? How it is different is that when all of the members are two-force member, we can actually just focus at the pin, and each force is straightway along the member, right, in the direction of the member, so it's straightforward. But when we have more than two-force members, so it will become XY, XY, etc. So we cannot just focus at the pin, we have to draw and solve for the whole member, basically. For example, this member here. Machine, how it is different is basically it will have moving parts like this thing here, right? It can move. Or even if like this, it have moving part when you apply the force. So this is categorically a machine also, right? So just by looking at this, you will notice that calculation-wise to draw the free body diagram, it will be more interesting, more fun, right? So. Because as we have covered in trusses, it's always repeating the same thing, the free body diagram, right? Here, everything is different. This is different than this one, etc. Okay. Now, so what are the steps for analyzing frame or machine? The example will always show frame, even though the step will be the same for machine. But if you by showing frame, it will make it seems easy to you, right? Or something. Because if you show machine, it will seem more complicated. Right. So this is a frame. Why? Because at least there's two member. This is two force member. This is multi-force member, which is 1, 2, 3 force member. So it becomes a frame. So when you separate the member, hopefully you understand the concept. When it is two force member, it's either compression or tension. That's why it's like this. And for non-two force member, then we have to consider X and Y. This one, why is it only one? Because it's corresponding to this one. If this is established as this should be the opposite direction, right? Now the step is one, draw the free body diagram. Now some hints or some guidelines for drawing the free body diagram. First, identify two force member, right? In this case, we have to first identify, okay, this is two force member. Why? Because the free body diagram will be different. If you know this is two force member. Otherwise, pin support it will anti X, Y, etc. Right? Now in this case, you straightway draw like this. Now, how is it different? Now, when you draw something like X and Y, how is it different than this? What is the difference? Now, as we have covered in chapter 2 perhaps, when you have x and y, actually this means it will have some resultant anyway, right? The only thing that why we draw like this, because we do not know is it like this or like this, etc. right? So the angle and the value will depend on the x and y component. When we draw like this, meaning that we of course it will have x and y component, but we know for sure the direction, the resultant must be in this line. So that's the difference. It doesn't mean that why doesn't it have x and y? It will have. It's already the resultant is known direction. So the unknown become 1. In this case, the unknown is 2. Right? So that's the thing about 2 force member. Alright. So first step before you draw or when you draw the free body diagram, identify 2 force member because it will have an effect in terms of the unknown. And then note the force on contactor surface are equal and opposite. For example, at this point B, so this is contacting surface. So if you assume this is compression, meaning this one should be like this so that it is the opposite direction, right? So when you combine, it cancels each other, right? If you assume this is tension, then this will be that direction, of course, right? And then the third one is, for a joint with more than 2 member or external force, it is advisable to draw a free body diagram of the pin. Okay, normally I like to avoid this kind of question. I mean, as a lecturer, as a student, kalau keluar kena baca. But as a lecturer, I avoid this question because it tests you to a bit a different level. For example, here is actually this is contacting between 2 members, right? If the question is something like this, right? Meaning you have 3 members at this contact point, right? So if you have to, when you draw this like this will obviously be like that, right? Of course, straightforward. But when you have 3, what will happen? If this is like this, is it here or divide or what? Because if you put the same value, then it is not matched, right? And if this is F and F, then when you combine, it's not cancel each other. Because this will be 2F, because it combines like this, right? So in this case, that's why I normally like to avoid this case. But I'm not sure what will happen in this final because every lecturer was assigned to make a question for each chapter, and I'm not assigned to this chapter, so I don't know what will happen to this chapter, so I cannot comment. Now, but the point here is, if that is the case, then you are advised to draw the pin so that everything is reacting to the pin. For example, if this is like this will be like that. If this is X and Y, this will be X and Y. If this is another 2 force member, for example, this will be like that. So that when you combine each other, all of this, it cancels each other, right? And this will be another free body diagram. Right? So this is the point number 3 here. If you have more than 2 members at the point, at the joint, it is advised so that you avoid confusion, meaning everything is here and then the calculation will resolve itself. Right. Normally you will not face question like this, but yeah, I'm just mentioning that. But in reality, for those who will be engineer for this type of things, you may have. But I'm talking, it doesn't. Normally we don't have in static in subject study, not in reality. Right. Okay, and then develop strategy to apply equation of equilibrium to solve the unknown. Now, as you can see, in this case you have 2 members, you have 2 free body diagram. But in this case, this one will not be effective in calculation because if you do this, it's just summation. FAB equal to FAB. You cannot solve anything, right? This will be your free body diagram. You have 1, 2, 3 unknown. You have 3 equations you can solve. Fx, Fy, and moment. But for if you just recall the type of drawing that we have just now, right? The frame with pulley, etc. And then there's a crane here, or what is it? Is it a crane or what do you call that? You have more than 2, 3, or 4 members, right? So that is where if you do not have enough exercises, you might be stuck not knowing which to start with, right? Because we have simultaneous many free body diagram and yeah. So problems are going to be challenging since there are usually several unknowns. A lot of practice is needed to develop good strategies and ease of solving. Okay, so they already state like this. Problems are going to be challenging. Do not be surprised. Oh, kenapa challenging? Because it is challenging, right? So you have to have a lot of practice. So do not be surprised if in the exam it seems so difficult. Normally that is because you have lack of practice. So you have, if you face that one, you say, inshallah next semester I practice a lot more. Okay? But before that happens, make sure you practice before the exam. Okay, that's even better. Alright, so we'll go straight to the example. This is a frame and only 2 members here. So yet again, the slide always use the easiest type of question so that you still hopefully you can pass it. So because the focus is for you to be able to understand how it is applied, right, the concept. But normally, rarely you see this kind of question in the exam. But anyway, so the frame is supported by external load. Find the horizontal. Okay, first, do you understand the question? Find the horizontal and vertical component of the print reaction at C. So what do you need to find here? CIC1, and then find magnitude of reaction at B. So the force between this and this, right? Okay, so when you draw, we have, in this case, you have 2 members, something like this. What's the first question that you need to ask just now? When you draw free body again? Is there any 2 force member? Which one? So AB, this one, right? So there's 2 options, compression or tension. Which one do you like to use? Tension. Ini luar perasaan tension. Okay, what do you understand? Okay, now it's not a problem. You just assume either tension or compression, and then when you get positive or negative, that means it's either that direction or the opposite, right? But you can actually guess which will it be, right? In this case, can you guess? Why? So if you imagine this member is being pushed down, so it will push this down, so normally it will be under compression, right? So right? And then because this is this direction, this will be that direction, right? So we'll label this FAB. Obviously it should be the same, and this is FB, this become FAB. Alright? What's the angle? How do you get the angle? Now, if you use a triangle, this is 1, this is 3, so square root of 10. You can screw. Okay. Or you can find the angle in theta. I have a personal preference to use triangle because it doesn't introduce any error yet. Right? If you calculate theta, you will have decimal point and you cut it somewhere. And when you multiply, the error can be big if you are not careful, right? In this case, until the end, you will keep the square root and then you calculate, then the error is only small at the end normally. Right? So that's just personal preference. Then you have this one 800 Newton meter, and then you have 400 Newton there, and then you have Cx and Cy. Of course, the direction is assumption. This is 2 meter, 1 meter, 1. So that is your free body diagram. How many unknown do you have in total? 1, 2, 3. This is the same, right? How many equations do you have? Basically, you have 3, which is summation of fx, summation of fy, and summation of moment. So which equation should you use first if you want to solve this quickly? Moment about? Summation of moment about point C, right? Why? Because it will cancel both. At that point, you can straight calculate for identity, right? So if you take counterclockwise, it's positive. This one will be positive 400 times 2. This one is straight with counterclockwise, so plus 800. This one, the vertical one will be clockwise, right? So minus, okay, FAB we don't know it yet, and then vertical 1. 1 over square root of 10, distance 3. Vertical 1, distance is 3, right? And then the horizontal one is still clockwise, so minus FAB 3 over square root of 10, and then distance of
10 and 1.
1. So 0. Based on this, FAB should be positive something, right? It's negative in here, right? So yeah, normally you can guess this is compression. But if you assume tension, then you just get negative, meaning it's positive. Alright, and then you can just summation of fx equal to 0. You'll have cx, no component, no exponent. This one will be minus, if you take positive to the right. So this minus FAB, you know already the value, times 3 over 10 equal to 0. So Cx will be positive, I guess, because this is positive, so it becomes positive. So the assumption direction is correct. Summation of Fy equal to 0, positive upwards. So you have Cy minus 400 plus FAB, the value that you know already, and then 1 over square root of 10 equal to 0. So Cy, I'm not sure, it depends on this value here. It can be positive or negative, depending on calculation. If it's negative, meaning it's just downwards. And then you have solved already the positive. Right. So this is just to show how to solve from free body diagram and then apply equation of equilibrium. Right. Of course, normally in the exam it will not be just this short, because now we are doing only one free body diagram. Normally there will be 2 or 3 free body diagram that you have to solve, because there are many components in that structure. Right. Any question? Alright, so if you take a look at the solution in the slide. So this is the free body diagram. Now, they are obviously assuming the same compression, so it's like this. But here it's actually the opposite compared to us, right? So it should be the opposite in this sense. So when they calculate for FAB, you should get this answer, should be the same, 843. Now, in the slide you'll see something like this. When you calculate and then final answer in 3 decimal point or 3 significant figure, right? But when you want to continue calculation, you should use this one, right? Because this one you have already round off and it will be an error. Should be like that. Now, Cx here it get negative. Okay, for us we get positive, meaning to the right. So they assume to the left and they get minus 800 Newton. So you see then it means 800 Newton to the right. Now, this is one thing. In the exam, for example, you get Cx equal to minus 800 Newton. This is based on this. For us, it will be positive, right? You should state something to indicate that you understand what this meaning. If you state some direction as well, then okay, we assume you understand. Because if you do a little bit like this, it is not clear whether you understand or not. Because for example, in -2 degrees Celsius, what does this mean? It's actually the value, right? Negative, below 0 is negative. But this is not like that. This is the direction. The value is 800, but that direction, right? So you have to clearly indicate that you understand that, especially when you get negative. And see why they assume downward, they get negative, meaning it's upward. For us, we assume upward, so you will get a positive value also here. Right? So it's not a problem which direction you assume, as long as you indicate clearly in the end what does it mean. Any question? Okay. Alright. Concept quiz. This is just to see whether you understand the concept that we have covered so far. Now this is similar that we have covered just now, right? Okay, for this structure of this is a frame. We have two members. This is two force member and this is three force member. The free body diagram will be like this. Okay. The person is not yet out. Okay, so if an additional couple moment is applied at C, so that's why applied here, how will you change free body diagram member B, C at B? Meaning this member C. How will you change this free body diagram at this point? No change meaning exactly. So originally they draw like this. Right here. So how will you change? No, A no change meaning still like this. B it becomes Bx and Bx By. C Bx By and moment. This one force like this at moment. Which one? A, B, C or D? You understand the question? The question says this goes to that. What happens if you add the couple moment here? Meaning you add here something like this. Obviously, this will be add something like this. But the question is what happened here? No change. Bx By, Bx By moment, Fd moment. How many of you say A? A? I need to answer. D. This one. A at moment. C is mana dia? Bx By moment. B? Why? What's the reason for your answer? Counter moment at. You want to counter this one? So you add moment. Meaning your answer is this one. Yang kata B ke kat B ke tadi? Ke C je? A? Ada kata A tak nama kan? Why is A? Apa yang A? Tak ada dah? Macam oh tak ada reason? Tapi ada reason? Yang mana ada? Ada yang lain? Now, okay, first thing before we add this moment, right? Why do you draw like this in the first place? Couple moment. This one is two force member. Okay, this one is two force member, and you assume compression. So that's why I draw like this. Now, when you add this thing, does this thing change? No. Still like this. So if this is the case, what should happen here? Okay, no, because this, why you draw this is from here, right? So jawapan dia A ya. Now, if you understand why you draw like this, the answer should be clear, right? Meaning, if you add something like something whatever, it doesn't change the fact that it's two force member, right? So this will stay like this, right? No, no, all right. Okay, the same question. Originally it's like this. This is the free body diagram. Okay, if an additional force, meaning that if you add force, let's say you force like that, how will you change this one? The same question, but the scenario is different. No change, Bx By moment, or add moment. Yang ni. Why? Moment. Okay, because this member now is no longer two force member, right? If you have something here, what you have here, x, y, For example, xy. So here you have to draw xy. Right? So make sure you understand what is the reason. Okay, so hopefully you understand that one. Alright. Okay, so when determining the reaction at joint ABC, what is that? Okay, if you draw the Venn diagram of this, how many unknown do you have? Okay, so similar to what we just total 3. Why? This is 2 for example, you have only one unknown here, x, y here, right? And then for this question, if you want to solve for B straight away, what is the equation, the easiest one? A, oh, this moment at C, right? This is exactly what we do. Okay, so there's a problem with this slide. When you only show one example, that give you false hope for the exam. So we'll go to some of the different type of structure that you can see, so that you will see, you will have a good picture of what can happen in the exam. Now, these are all the pictures from the book. Okay, these are trusses. We have covered trusses before. Those are examples. Okay, any of this can be in your exam. You have to go to frame and machine. Okay, 3D we skip, right? Alright. Mana? Okay, example like this. Any problem to draw figure diagram? What will be the body? That one. Now, in this case, okay, we are dealing with pulley. Now, for pulley, you always have two options. Either you want the pulley to stay as the part of the body, or you want to separate it. Right? If you make it stay as one body, so it will be something like this, meaning this is part of the body. In this case, you will have this is XY, tension here just accordingly, and then you have this outside. So it will be like, but if you decide to split it, meaning this pulley and this one, so this one is the same, this one is the same. How will you? Because the cable will be something like this. What is the contact point? Contact point is here, right? So what should we draw? Between this one, what should be here? So because this is pin, normally, right? So you have X, Y. So this will be the opposite to this one. Okay. If you choose this one or this one, the answer will be the same. It's just that this one you add another calculation step, right? So that's how to deal with pulley. In this example here, it separates the pulley. For example, this one, how will you draw free body diagram? Okay, if you want to take out the pulley or you want to make it remain as part of the body? Okay, so if you have that case, something like this. If pulley is still part of the body, so it will be something like right? Now, if you totally take off the cable, okay, what happened here? X, Y, right? Here? Now, there's a cable here. Let's say T. There's a cable here, T. There's a cable here, T. Right? Of course, these will cancel each other. And then here, okay, this is 500. Of course, this is 500. And here also 500. So it will be something like that. Any question? This just browse to different type of possibilities. Okay, so pulley is not that difficult. Of course, normally when you calculate pulley, normally the issue is if you forgot to add the radius for the distance, right? Because sometimes this is quite clear, it's big, but sometimes this equation the radius is quite small, so make sure you don't forget that one. In this case, if they take out, then you will have something like this, meaning you have more Fibonacci diagram. Right? Okay, for this one, easy or difficult? Easy, right? Saya try kan? Senang sangat. Okay, what is the first question that you should ask when you want to draw Fibonacci diagram? Is there any 2 for example? Is there any? Where? Okay, this one. They have A, B, C, D. Okay. Where? E. This one. Okay, this one is 2 for example. Any other? IH there is 2 for example. Any other? This one 2 for example. This one 2 for example, right? So that's already make it quite straightforward. So how many? Because normally 2 for example we don't need to draw, but if you want you can. So in this case we'll have this like that, and then something like that. Right, and the rest is 2 for example, right? Only you know the compression of tension. Alright, so if you start, where do you want to start? If you start here, right? If you say IH is 2 for example, straight away you know the direction. If that is not 2 for example, then you have XY. Right? Of course, the direction is still assumption. What about point F? So? XY there. What about point E? This is 2 for example, right? So assume something like that, for example. Most probably like that, but anyway. And then point C. 2 for example also, right? I'm assuming everything tension here. Point D. XY. If you assume like this, meaning this one will be like this, the opposite to this one, right? And then point A. 2 for example. G is the weight. So it will be like that. Right. How many unknown? Okay, depend on what is given. No, if the weight is given, this is 1 unknown, 2, 3. Is it the same? 4, 5, 6, 7, 8. But 8 How many equations do you have? Okay, normally it's because it depends what is given in the question. Right, because normally if you have 2 unknown and 2 Fibonacci diagram, you have to solve 6 unknown. Because you have 3 equations here, 3 equations there. If you have 3 Fibonacci diagram, you have to solve 9. For example, that's the ratio we see. But yeah, the Fibonacci diagram is basically like that, right? So it's basically the same. The assumption direction is obviously different, but the rest is, the concept is the same, right? Okay. So I think if you understand that already, it's not difficult, right? Let's just go through. Okay, what about if you have this kind of pulley? So how many Fibonacci diagram? How many? If you draw for each pulley, so you have 1 pulley down here, 1 smaller pulley up there, 1 bigger pulley up there, something like that, right? Now let's say you start with, where do you want to start? Start with P here, right? So this, if this is P, what will this be? P also. Why? It's the same cable, right? So this one is, let's say F over. What about this one? Okay, is there any 2 for example? Basically this is 2 for example, right? this one also lah, tapi ni dah sebelum kita can see betul sini lah. But that was 2 force member, meaning let's say this is F, apa nak bilang ni, BC kata kan. So this will be BC, right, corresponding. If this is P, what will be this one? P also, meaning this one? P. Okay, boleh gini. Meaning this one? P. What is this one? P. If this is P, what is this one? P, right? This table here. From here you know here, from here you know this one, from this you know this one, from this you know this one, right? You follow the cable. And this one is 600. If the question say what is P, can you, is it simple? Just summation of this one equal to 0, P plus P minus 600 0, P equal to 200, right? So, as long as you can establish the free body diagram, normally the question becomes easy if you have a lot of pulley. Because a lot of the force will be the same, right? Even though originally it might seem complicated, but it becomes easy if you can follow the, right? So it's something like this, right? Okay, this one, ini pun banyak pulley juga. We are trying to see, okay. Some question might actually include the distributed loading, so make sure you understand what to do with distributed loading to become one force, and then the rest is just okay, what do you have here? This one becomes 1, distributed loading, this one, this one. Is there any two force member? This is not, right? So this one you have XY, right? What do you have here? XY and moment, right? That's fixed. Okay, so we understand that one. So something like this. Okay. Dah tunjuk lah. So, if you have question like this, what do you do? How many free body diagram? First one obviously is this one. Okay. And then if you follow the cable, okay, that pulley C is not important because it's just this tension becomes that tension. Pulley T is also not important, that tension is just tension. But pulley E is important because it relates to the side, right? So pulley E here. Okay, if you have this, what label here? Okay, if this is T, this one will be, this one will be T, this one will be T, this one, if you want to label, apa nak label? What will be here? So, if this is F H, this one will be F H, right? What will be the reaction here? What should I draw here? Apa yang downward? Like this? Downward? Why? Yeah, from the perspective of this one, does it experience being pushed down or being pulled up? It's being pushed down by this person, right? So it will be something like this. For example, this is F, upward, angle. But something is missing here, obviously, because in this case, this is up, this mine will go to the sky. So normally there will be a weight is to counter that one, right? The question is, I think, yeah, there's a weight there. The question, because this is just the diagram, right? This is the full question. So the question will specify the weight. Oh, yang ni pun ada weight juga. Okay. So if the question give you weight, then you have to put the weight. Dan ni apa tadi? Ada benda yang nak buat tadi. Okay, I forgot. This one is a roller, right? So, let me see. Okay, because I didn't consider that one. So this one is X and Y. Okay, ada lagi ke yang menarik? Senang kan? Senang juga. Okay, again, similarly, what's the question? Is there any two force member? This one two force member, right? And then this one If it's pin XY, this one cable, so this one XY, right? No, is it XY? If this is 2 force member, then you have only one outside, something like that. This one, okay, kita skip yang senang-senang ni. Cari benda yang senang juga. This one, do you think you can do? Yang ni masih agak senang lah. Because you only have 2 or 3 member, right? What do you have here? What will be here? When you separate, that's why, right? Because this is like a pin. What will be here? You pernah tengok makhluk ni kan? Oh, tak pernah tengok ni? Cakap gambar yang macam benda. Because if you cannot even imagine what's going on here, what will be there? In terms of this one, what will it do? It will be under compression, right? So at this thing, you will have something like that, and that will be like that, right? Tak ada jawapan. Okay, let's take a look at. Okay, are you familiar with this one? What will happen there? Because the rest, I'm not focusing on what you want. This one you know, this one you know, this one you know. This one, what will happen? Slide. Yeah, it means that it is free to slide within this hole here, right? Within this hole. But so how do you draw the direction? What is free to move? What is restricted? So is it free to move here?
Yes.
Is it free to move here? No. So there's a restriction there, right? So meaning when you draw this member here, the restriction is, for example, like this. You cannot do both, then it cancels each other. Because you are assuming it's either this one or this one. Because if you want to go there, the restriction is there. Here, if you meaning it's either one, right? And then we see. If you draw like this, then for this thing, it will be like that. Alright. So as long as you can imagine the mechanism. Okay? Okay, nak ambil masa dah? Okay. Tak sampai soalan susah ni. Tak semua senang ni kan? Tak ada susah. Ni senang ni. Normally if you get something like this, I'm not sure, I don't know why student tak jawab. Sebab dia terlalu senang. Because you have P, because you have many same unknown, right? Similarly like this, yang ni pernah keluar dah. Kan? Make sure you are able to differentiate because this one is P, this is P, this is P, right? But this is two different, when it's attached like this is P, this is something else, right? This is, let's say T, this one is T also, right? So there's only two unknown, for example. Ini pun senang juga. Okay, distributed. Mana je? Okay, kita lajukan sikit. Mana tak sampai. Okay, this one. Because we are running out of time, so please try soalan-soalan macam ni to see if you have any problem. Kalau problem kita boleh discuss in the next class. If tak ada orang tanya, saya assume tak ada problem, kita terus chapter seterusnya. This one, ni pun pernah keluar exam juga. The same question, is there 2 force member or the 2 force member, etc. Then this is pin, so it's quite simple. The only issue is if you cannot even imagine what happened here, for example, right? Okay, in this case, normally you do not detach, meaning this one and this one you still take as the same thing. Memang suddenly. Okay, some of this one also pernah keluar, have come out in the exam also. So you have to detect what is there in the 2 force member. So this one, how many member you have? 1, 2, 3. Of course you have this one and this 2 force member, right? Another one. Okay, this one pernah keluar. This one quite interesting. Sebab ada yang tengok pun dia kata. I think because I want to show another one where most of the students simply give up and do not answer. Easy. This one. I think I still remember when this question come up, 100% of students just leave it blank. Not sure why. Tapi nampak macam mengagumkan. But okay, so please take a look at this type of question and just try to draw the free body diagram. If you don't have any problem with this, inshallah it will be, because after the free body diagram is settled, the rest is calculation is straightforward. So do have a try, and in the next class, in next class, because we already have complete chapter 6. Next time we'll go into chapter 8. We'll have a quiz on trust maybe. But if you have any question in any of this, please point out so that we can discuss. Otherwise, I assume nothing is mudah ready, so I will not waste time to discuss. So with that, we end the session. Inshallah, subhanallah. Okay, assalamualaikum warahmatullahi wabarakatuh.